So we've looked at basically solving for an unknown exponent, and oftentimes the problem is presented in this manner, where it's log base 3 of 9 equals x, and we end up rewriting it in exponential form to get 3 to the x equals 9, and we figure out, well, what would x equal? We make 9 3 to the second. Okay, so x is 2. You could rewrite an exponential. You could also just think about it and say, okay, well, log base 3 of 9 means 3 to what power gives me 9? Oh, I know that's 2. And you could solve that way. So there's a couple ways of going about solving for an unknown exponent. But what about if you have an unknown base? Let's take a look at some examples. So this first one here, log base x of 64 equals 6. Well, what I can do is, again, I can rewrite this in exponential form, kind of like we were doing before. X to the 6th equals 64. So x raised to the 6th equals 64. Okay, so what raised to the 6th is going to equal 64? That's what I'm solving for. What raised to that particular power? Well, if you remember all of your perfect squares, cubes, fourths, so on and so forth, you'll know that this one is 2. Because really you could rewrite this as x to the 6th equals 2 to the 6th, then you know that x is going to equal 2. So, boom, there's my answer. And we can, once again, rewrite these other ones in exponential form to solve for that missing base. So let's do that with the other ones. Pause it, press play when you're ready to check. So rewrite it. So I've got x to the negative second equals 1 over 49. And then we're going to think, okay, well, what raised to the negative second gives me 1 over 49? Well, let's think positive exponents. So it'd be really x squared equals 49. So what would that be? Well, that would be 7. This x squared is 49, so x to the negative second is 1 over 49, because negative exponents give us reciprocals. Cool. And lastly, we get x to the third equals 216. Now we got to think, okay, what raised to the third gives me 216? And some of you actually might have already thought, could I bring back in, could I bring last chapter back in here? You absolutely could. How would you undo something cubed? You could cube root it. Boom. If I cube root 216, I'm going to get x equals 6. Nice. I could have done the same up here as well. 6th root of both, or raising to the negative, or raising to the 1/6. So, options, people, options. Okay? I personally like to problem solve a lot of these. Most of them are going to be nice numbers for you, but if you need to, you can always cube root, or 4th root, or 5th root, or 6th root, or so on and so forth. Cool. If we're solving for an unknown base, we want to put it into exponential form. And you could use roots to solve. You could also just problem solve if you'd like. You know, a couple options there. And lastly, what if we have an unknown answer, meaning log base 3 of x equals 6? What the heck do I do? Once again, how about we put it in exponential form? Okay, so I'm going to have 3 to the 6th equals x. Well, I need to know what 3 to the 6th is. And 3 to the 6th is 729. Cool. Okay, so now we've got log base 4 of x equals negative 2. And once again, you can pause the video, try these, press play when you're ready. Alright, if I rewrite her in exponential form, I get 4 to the negative second equals x. Well, 4 to the second is 16, so 4 to the negative second is 1 over 16. Nice. And then lastly, now this last one, actually, if you go through and solve it, and we're going to talk about this after, if you go through and solve it, you'd have 1 to the 5th equals x, and that means that x is going to equal 1. But let's think about this for a second. If I plug 1 back in, log base 1 of 1, well, 1 to what power gives you 1? Well, 1 to the 0 does, 1 to the first does, 1 to the second, 1 to the third, 1 to the fourth, so on and so forth. So you can have like an infinite number of answers. Well, what's actually true is you can't have a base of 1. And the reason being is if I were to plug that 1 back in, I wouldn't get 5. Log base 1 of 1 is not 5. I can't do it. So You can't do this particular problem. Whoa! You cannot do this particular problem here. We won't give you ones with a log base of 1, but we just wanted to show you there because that's fun.